Hello everyone, this is Dr. Fan. The relationship between kinetic friction coefficient and the incline angle is a very popular question in AP Physics, and today we are going to use two practice problems to understand their relationship. So the first question says, when a block with a mass of m is released on an inclined plane, it slides down at a constant speed. What is the relationship between mu k and the incline angle theta? And mu k is the kinetic friction coefficient between the block and the inclined plane. Since this question is asking the numerical relationship between mu k and the angle theta, we definitely need to do some calculation. And the key word for this question is moving down with constant speed. So if the block is moving down with constant speed, that means the acceleration is zero. So what can we learn from acceleration? We know the net external force equals to mass times acceleration. If acceleration is zero, means the net external force is zero. Then what we can do is we can construct the free body diagram. So the block is under gravity going down, and the block is under normal force perpendicular to the ramp. When the block is moving down, it also experiences a resisting force, which is friction. So friction is going this way. So this is the free body diagram. So from the free body diagram, we can learn the net external force along x direction and the net external force along y direction. So if I construct going down as my positive x direction and perpendicular to the ramp is my positive y direction, if this angle here is theta, I know this angle is theta too. So then I can decompose gravity into a component parallel to the ramp, which is Fg times sine theta, and a component perpendicular to the ramp, which is Fg cosine theta. Knowing this, I can find my net external force along x and y direction. Let's look at x direction first. So we have mg sine theta, which is the horizontal component of gravity going down, which is positive. So mg sine theta minus friction, because friction is opposing the motion, and which equals to mass times acceleration along x direction, which is 0. Along y direction, I have normal force, and I have a vertical component of gravity, which is mg cosine theta, minus mg cosine theta equals to mass times acceleration, and which equals to 0 too. And in this case, I can find my normal force right away. My normal force equals to mg cosine theta. And because the block is moving, so the friction force here is kinetic friction. And we know the kinetic friction force equals to mu k times the normal force. And this is my normal force. So my kinetic friction force is mu k times mg times cosine theta. And from this equation right here, I know mg sine theta and my friction are the same. In other words, mg sine theta equals to mu k mg cosine theta. So if I cancel mg and mg, what I get is sine theta equals to mu k times cosine theta. If I divide cosine theta on both sides of the equation, I get sine theta over cosine theta, which is mu k. Sine theta over cosine theta is tangent theta, so I got my final answer, which says mu k equals to tangent theta. So the correct answer is C. In this case, we can see that a block can move down with constant speed if the tangent theta and mu k are the same. And this relationship has nothing to do with the mass. So you can be heavier or lighter as long as the angle and the kinetic friction coefficient has this relationship, the block can move down with a constant velocity. So what if tangent theta does not equals to mu k? If we look at these two values here, mg sine theta is the force pulling the block down, and mu k mg cosine theta is the friction force opposing the motion. if we have mg sine theta larger than mu k mg cosine theta. If we simplify this, we get tangent theta larger than mu k. In this case, because the force pulling down is larger than the opposing force, so the block is gonna accelerating, right? So when tangent theta is larger than mu k, it's gonna accelerating downward. Similarly, when tangent theta is smaller than mu k, it's gonna go down, but it's gonna decelerating. Okay? So when a block is moving down, depending on the relationship of tangent theta and mu k, a block can move down with constant speed, or it can be accelerating or decelerating. Alright, now let's look at the second question. So the second question says, a person applies 20 Newton on a block along the ramp direction. So this is 20 Newton along the ramp direction, which makes the block go down with constant velocity. And the question asks, what's the force needed along the ramp direction if the person wants to push the block up with the constant velocity? So in this case, it's pushing it up and asking what's the force here. And there are some other information. It says the mass of the block is 10 kg and the incline angle is 30 degrees and the kinetic and static friction coefficient are the same, right? Okay, so this question involves two motion. One is going down, one is going up. Let's evaluate the going down situation first. Under this situation, the block is under gravity, and there is a normal force perpendicular to the ramp. There is also a force F equals to 20 pushing the block down. So because the block is moving, so there is kinetic friction opposing the motion here. And we can do the same thing as we have done before. We can construct a coordinate system and we can find the net force. So if we use this direction as my positive x and the direction perpendicular ramp is my y direction, I can get my net force. So this angle is theta, so this angle is theta. Let me first write down the net external force along x direction. So sigma fx for the going down situation equals to, I have this pushing force F, and I have a horizontal component from gravity, which is mg sine theta. mg sine theta. I have kinetic friction force opposing the motion minus F friction kinetic, and which equals to mass times acceleration. In this case, because it's moving down with constant velocity, so the acceleration is 0, so this is 0. And along the y direction, what I get is I got normal force, so Fn. I also got the vertical component of gravity, so which is minus mg cosine theta, which equals to 0, 2. So in this case, I can find my normal force. Fn equals to mg cosine theta. I can also find the relationship between applied force and friction and gravity. In this case, the applied force equals to the friction force minus mg sine theta. So this is the relationship I get from the downward motion. How about the upward motion? So for the upward motion, I can do the same thing. So for the upward motion, I have gravity going down. I have normal force going this way. I have a force pushing along the ramp going up. Let's call it F prime. And in this case, I have kinetic friction going down. Because I want to push the block up, so I use this upward direction as my x and the direction perpendicular to the ramp as my y direction. Then I will do the same thing. This angle is theta, so this angle is theta. So what's the net external force along x direction? So sigma fx equals to the applied force F prime, and then minus the gravity's horizontal component. So minus mg sine theta, because mg sine theta is going down, and then minus the kinetic friction force, and which equals to mass times acceleration, which equals to 0, 2, because I want my upward motion also has constant velocity. So along the y direction, sigma Fy, which equals to normal force, this guy here, minus the component of gravity perpendicular to the ramp, which is mg cosine theta, which equals to 0 because there is no acceleration. So now I get my normal force, which is mg cosine theta. I can also get the relationship between the applied force and gravity and the friction force. In this case, it's F prime equals to mg sine theta plus F, the kinetic friction force, right? If you look at the result here, the normal force for both situations does not change. And we know the kinetic friction force equals to mu k times normal force. Because it's the same block, it's the same ramp, so mu k would not change. And since normal force is not changing, that means the kinetic friction force here and the kinetic friction force here are the same. So if I call this equation 1, I call this equation 2. If I use equation 2 minus equation 1, what do I get? I get F prime minus the applied force in the first situation, which is 20 Newton, equals to 2 mg sine theta, because the kinetic friction force is gone. And if I plug in all the value, what I get is F prime is 120 Newton. So the correct answer would be C. In this question, some students might choose D because they think the friction coefficient is not given, so they cannot find what force is needed. But in reality, in this case, you can actually solve the kinetic friction coefficient. I'm gonna leave this question to you guys. Can you find the kinetic friction coefficient? And what's the relationship between the kinetic friction coefficient and the tangent theta for this question? Alright, that's what I want to discuss today. Thank you. I will see you next time.